Hello everyone, my name is Yukun Xia. In this project, I implemented the feedback motion planning idea on the pendulum. Based on that, I created a graph of funnels, which could be potentially useful for kinodynamic planning. There are mainly two parts of my project. One is to construct funnels, and the next is to plan with these funnels, and also one surprise here. In the first part, the procedures are very similar to the ones introduced in class. We start from randomly sampled trajectories by trajectory optimization, use TV LQR to stabilize the trajectories, and the last step is to use SOS programming to calculate the size of the funnels along the trajectories. So here's are the randomly sampled trajectories and 200 randomly sampled trajectories. Here's the visualization of the funnels. The left figure shows the new sampled trajectories, and on the right-hand side, those are the corresponding funnels. Finally, I got 120 trajectories and funnels. As you can see here, the state space is well covered locally. The next is how to plan with these funnels, because new starting and ending point are not necessarily inside these trajectories. There are mainly two difficulties here. One is how to dynamically shrink the size of the funnels, and how to quickly check whether a funnel contains a given point. So for the purpose of the demonstration, one assumption made here is if point A is inside the ellipse of point B, then the movement from point A to point B is assumed to be doable. So lots of the interfunnel connections represented by the green arrows are added to the graph. So let's see under this assumption, where could we achieve starting from the origin? So as you can see here, as the iteration number increases, more and more points become red, which means become reachable. After 21 iterations, most local region here is reachable. So potentially in the future, with the help of these funnels, I can swing up the pendulum. One surprising phenomenon here is the clustering of funnels. As I increase the value of the R matrix here, more restrictions is imposed to the input so that it's clear to see the clusters of the funnels centered at the fixed points. One interesting question here is, does the clusters mean different dynamic modes? It seems easier to move internally, but harder to move externally. So you can check my project report if you are interested in more details and analysis. Thank you.